Okay, just so you know what's going on in the example below, it uses a thing called a normal distribution. Now, lots of things, like lengths of earthworms, are distributed so that near the mean value, which we use the symbol mu for, we have the most likely outcome at the mean, and then the further away we go from the mean in each direction, outcomes become less likely. So what tells me how likely something is how much area it occupies here. So a single value could never have any probability, because the probability of getting an exact measurement spot on in real life is 0. However, a range of measurements would have an area connected with it. And it's how much area we've got, the total area, because it's a probability, will be 1. How much this area is will tell me the probability of being between these two values. Now, the probability tails off as we've seen, so we need a measure of how far away we are from the mean. And what we actually do is we measure that in terms of standard deviations. So the value that tells us how many standard deviations we are away from the mean we call z, and it's calculated by doing a particular value, call it x. If we take that value and take away the mean, that's the distance that x is away from the mean. But if we then divide that by the standard deviation, which we call sigma, then that tells me how many standard deviations I am above or below the mean. Notice we stopped using x bar and sx for mean and variance, because the mean is the mean of the entire population, which I can't observe. We use x bar when we're working with data we've observed that we've got in a table, and that's the mean of the sample. And similarly, sigma is the mean of all the data that's out there in the population, not just a particular sample. So z tells me how far away from the mean I am, measured in standard deviations. And it turns out that all I need to do to work out a probability like this is I need to know the z values corresponding to these endpoints here. So what's that z? What's that z? Okay, this is how the z's are calculated, and then I can use my calculator in a relaxed and groovy way to enter the z values as my limits. So normally I'm going to have a lower limit and an upper limit, and the calculator will cunningly tell me that probability. This camera is really weird on here. Okay, but I think you can see that picture all right. So this is a fairly low quality video, but it hopefully has set the scene for the video lower down this page, which you will enjoy. So watch that one, and it will show you how to do the questions. Have fun.